Hello and welcome to my video on the leaky bucket algorithm for congestion control. My name is Sumanth Kargar of EOS and 2SD21EC102. Today we will be exploring how the algorithm helps manage network traffic and prevent congestion. Let's get started. In the introduction part, first let's talk about the network congestion. Network congestion occurs when a network node is carrying more data than it can handle, leading to packet loss and delays. This is where congestion control mechanisms come in. Traffic shaping is one such method that helps smooth out the traffic flow to avoid congestion. In this video, we will focus on one specific traffic shaping algorithm, the leaky bucket algorithm. Understanding the leaky bucket algorithm. It's a simple yet powerful method for regulating data flow in networks. Imagine a bucket with a small hole at the bottom. Water representing incoming data packets is poured into the bucket, and it leaks out a steady rate through the hole. This analogy helps us understand how the algorithm works. The bucket represents the buffer capacity, the water represents the incoming data packets, and the hole represents the constant output rate at which packets leave the bucket. How the leaky bucket algorithm works. Let's break down how the leaky bucket algorithm works step by step. First, we initialize the bucket with a fixed size and set a constant leak rate. When packets arrive, they are added to the bucket. If the bucket has enough space, the packets are stored. If not, any excess packets are dropped, simulating packet loss due to overflow. Packets leak out the bucket at a constant rate, ensuring a steady output flow regardless of the burstiness of the incoming traffic. Some applications of the leaky bucket algorithm are leaky bucket algorithm has several applications in network management. It is used for traffic shaping, which smooths out the bursty traffic and ensures a more consistent flow. It also helps maintain quality of service by preventing network overload and ensuring that data transmission remains smooth and reliable. Additionally, it is used for rate limiting, ensuring that the rate of outgoing packets does not exceed a predefined threshold, which is crucial for managing network resources efficiently. Comparison with token bucket algorithm. Now let's compare the leaky bucket algorithm with the token bucket algorithm. The leaky bucket algorithm provides a constant output rate and can lead to packet drops during traffic bursts if the packet capacity is exceeded. On the other hand, the token bucket algorithm allows for variable output rates and can handle bursty traffic more flexibly as long as there are enough tokens to transmit the packets. This makes the token bucket more adaptable in certain scenarios, but both algorithms have their own use cases. Now coming to the simulation. Now coming to the explanation part. The bucket structure contains size and water. Size means the maximum capacity of the bucket, and water means the current amount of the data in the bucket. In the initialization part, init.bucket initializes the bucket with a given size and sets the initial water level to 0. Adding to the bucket. Add to the bucket adds incoming packets to the bucket. If the addition would overflow the bucket, it reports the overflow and sets the water level to bucket's maximum capacity. Leaking from the bucket. Leak from the bucket simulates the leaking of packets from the bucket at a fixed output rate. If the bucket is empty, it reports that there are no packets to leak. In the main function, in the main loop, the program continuously prompts the user for the number of incoming packets, adds these packets to the bucket, and then leaks the packets from the bucket. The sleep one simulates the passing of 1 second between the iterations. Now let's do an example. Let's run this code. To better understand how the leaky bucket algorithm works, let's look at a simple example. Imagine we have a bucket size with a size 10 of 10 packets, which is in this code, and a leak rate of 1 packet per second. If 15 packets arrive at once, Then 10 packets will be stored in the bucket and 5 packets will be discarded due to overflow. The bucket will then leak 1 packet per second until it is empty. Ensuring a steady output rate, this example demonstrates how the algorithm regulates the flow and prevents congestion by maintaining a consistent output rate. Now coming to the advantages and disadvantages. Like any algorithm, the leaky bucket algorithm has its own pros and cons. One major advantage is it has simplicity and ease of implementation. It provides a steady output rate which is beneficial for network stability. However, it also has some disadvantages. During net traffic bursts, it can lead to packet loss. If the bucket capacity is exceeded, additionally, it is less flexible than the token bucket algorithm in handling variable traffic rates. To summarize the leaky bucket algorithm, it is a useful tool for congestion control in network traffic shaping. It ensures a steady flow of data by regulating the rate at which packets are transmitted, preventing network overload and maintaining quality of service, which it has some limitations. Its simplicity makes it an effective solution in many scenarios. Thank you for watching my video on the leaky bucket algorithm. I hope you found it informative and helpful. If you have any questions, feel free to leave them in the comments below. Thank you.